फुल स्क्रीन करना
तो लगा ना साइड में फुल स्क्रीन પછી
पीपीटी में फुल स्क्रीन करना पड़ेगा
પ્રેઝન્ટ માં
हाँ
એની પણ સ્ટ્રીમિંગ તો ચાલુ નથી કર્યું ને
हाँ प्रेजेंटेशन में આપણે ઓલું ફૂલ F5 કરીને કરીએ ને સ્ક્રીન
ઓડિયો બંધ રાખવું પડે કે
हाँ
Good morning, everyone. Today, I'm going to present you the webinar on Introduction to PLC. So, what is the main objective of today's webinar? At the end of today's session, every participant should be able to first differentiate between the microcontroller and the PLC. Then after, you will be able to describe the major component used in the PLC. You also will be able to interpret the different specification of the PLC and understand what is the basic PLC operation cycle. And at last, we try to learn about some basic PLC problem. So let us start with what is PLC. So we can say that the basically PLC is known as the industrial computer, and that is used to make the automation task of the industry. So your PLC is capable of storing some instructions and implement the control functions like sequencing, timing, counting, some arithmetic functions, data manipulating tasks, and the communication between the modules. And this can be done with the help of different IO interfaces, which is going to be used with the PLC to make the communication between PLC and the outside world, and that are input and output modules or input information providers will be like push buttons, some sensors, pressure sensor, temperature sensor, like that, that will be used as the input components, and output devices like control valves, relay, lamps, everything. So that's going to be connected at the output side of the PLC. So in short, PLC is the industrial computer which will take the information from the information provider, that is the input devices, and it will do the computation on it. It will be executing the program instructions, and according to that, whatever task required to be performed, it will be passed on to the output, and with the help of output devices through output modules, it will control the output task. So this is what the basic about PLC, that we can say PLC is nothing but like it's industrial computer which is used to particularly control the industrial task. Now, if we talk about the history of PLC, the very beginning of invention of PLC, we can say start the General Motor Corporation, and they have started to develop PLC just to replace the complex logic made up by relay control, and also to reduce the cost, as well as to make it flexible to change something inside the controls. So from that, PLC has been came into the market, and they have started. It has started to develop. So you can say before the PLC, there were control structure or automation was only possible with the help of relay logic, and that relay logic is very complex, and it will be taking much time to solve the errors and to find out the problems in that, and it is only able to be made automation for a short or small part of the industry, but the whole industrial automation was not possible with the help of that relay logic. So the PLC invention started, and the PLC is now there in the market. Now, what are the advantages of the PLC? The main advantage of the PLC, that we can say, there is a very less wiring required. Only we need to connect the input devices and output devices with the input and output module of the PLC. Remaining all kind of relay logic wiring is just going to be virtual inside the PLC program instructions, and that's why very less wiring required in this PLC. Then after the wiring between device and relay contacts are done in the PLC program. That's what I feel. And very easy to make changes in the logic. In hardwired relay logic, if you want to make some changes in your logic, it will be very difficult to reconnect all the relay contacts and all that thing. But in PLC, as it is in a virtual logic diagram into the program, so it will be very easy to make any changes required to change your operation or cycle of the automation cycle. Even it will be very easy to get troubleshooting of the problem occurring during the operation and into the PLC, instead of that what relay logic we are comparing here with. Then after reliable components which is used in the PLC, it will make it to be used for a longer period of time. So the use of PLC can be longer period of time, means the problems coming are very less in the case of PLC logic. Now, what are the leading brands which are going to manufacture PLC? So in market, we are having different brands. If we talk about American brands, there is Allen Bradley, Glenn Modigan, Texas Instrument, General Electric, Westinghouse, Cutterhammer, and Square D. These are the American brands of the PLC. And some European brands are Siemens, Klockner and Moller, Festo, Telemecanique. Then Japanese brands are Toshiba, Omron, Fanuc, Mitsubishi, and the German brand is the Bosch Rexroth. So these are the various companies manufacturing the PLC. Now, how the PLC looks like for the different companies. So if you just look at these pictures, you can see that the PLC from the various companies are having the various different types of look. So here you can see that Allen Bradley PLC, Omron, Siemens, Festo. So these are the different PLC. You can see that how they are looking actually in the physical thing. Now, where are the area where we can use the PLC? So there are various areas like manufacturing, machining, food, beverages, metals, power, mining, petrochemical, chemical industries. So there are all can use the PLC in automation. Now, if we just make the comparison between PLC and PC, because most of us having the often confusion between the comparison of these two, that if we are having the microcontroller, or you can say microprocessor, to do the task, then why we have to go for the PLC? So the basic difference between the PLC and PC, you just look at here that in this various tasks, like if we just compare CPU and memory of the computer and PLC, then it looks both are same. In computer, we are having hard disk to store many number of data, whereas in PLC we'll be having a small memory which is in the flash card form. Power supply is also almost same. The inputs devices in computer and PLC are different. We can see that input devices in computer are keyboard, mouse, remote station, LAN connection like that. Whereas in case of PLC, our input devices will be like push button, some selector switch, limit switch, some sensors like that. So it is their difference in the input connections or input types of devices. Then
Sorry for inconvenience. All participants are requested to wait for 2 to 3 minutes.
Sorry for disturbance. Now everything is okay, so we can start with. Let's move to the point where we are discussing. We have seen this leading brands. Then we have seen this how the PLC looks like from the various brands. Then we have seen the areas of the application, and we were discussing at this point that is the PLC and PC comparison. So as we are discussing that the main difference in inputs devices to the PLC and PC, that is in case of PC we are having keyboard, mouse, remote station like LAN connection and all that. Whereas in case of PLC we are having input devices like push button, selector switch, some limit switches, or some sensors like pressure sensor, temperature sensor, or some interfacing connections like bus interface and all that. And similarly, if we compare the output device between PC and PLC, that PC will have monitor, printer, projector, etc. Whereas PLC will have to control some output devices like solenoids, relays, contactors, lamps, motor controls, like that. Now, like in PLC, PC, we are having Windows as an operating system. That is what we call it as a software in computer. Similar that in PLC, we are having the firmware, which is like operating system of PLC, you can say. Then in computer, we are having internal devices like calculators. In PLC, similarly, we are having markers, timers, counters, function blocks that is going to be directly used to process some task. So this is a simple comparison of PLC and PC. Apart from this, if we just want to highlight the main difference, then we can say in case of PLC, there is a large number of inputs and output device handling capacity compared to the microcontroller or microprocessor, because microcontroller and processors are coming in small package like 40 pin package or 30 pin package like that. So in that we are having very less number of inputs and output device handling capacity, whereas PLC is able to have input devices or output devices in terms of, like you can say, the number of thousands, and that's why it will able to have a very large number of inputs and outputs handling capacity. Apart from this, microcontroller and microprocessor are developed to work with a normal temperature pressure condition, that is what in our office area, whereas PLC is specifically designed to work in the industrial environment, that is it can withstand some high temperature pressure conditions, even dusty environments and all that. So PLC, we can say, a specifically designed industrial computer that can be used to perform our industrial automation tasks. Now look at the major component of the PLC. So what are the major component of the PLC? The major component, if we just start with the heart of PLC, that is the processor. The processor is connected with the power supply. The power supply will give the power to processor first, then processor is used to perform the comparison, logic operation, sequential task, timing task and all that. So that all processing is going to done by the processor, but for doing all this process you require to give the information of the outside world to the processor. So the information from the outside world, that means the industrial environment, or you can say the temperature condition, pressure condition, all that things in your plant, that need to be provided to the processor, and that is going to be provided to processor through the input module. So processor is going to be connected with the input modules, Another thing is that programming device. As I said, that processor is used to do the task or the process execution. It is required to be given the instruction set. That is what we call it as a program. It means program is a list of instruction in which sequence you want to perform your automation task. So that sequence of operation you need to write down in a program, and that program is going to be added into the processor. Then processor is going to execute it. So to add the program into processor, we have to use the programming device. So programming device is also going to be connected with the processor. And another thing, that's what I just told, that is the input module. Means after you add the program to your processor, you require to provide the information from the outside world, and that's going to be done with the help of input module. So input module will be connected to the processor, and that input module is connected with the sensors and the input devices like push buttons, limit switch, etc. So from that input devices, information will be first passed to the input module, and from that input module, your information will be converted into the form required by your processor and given to the processor. So after having processor input information as well as the program, processor will start executing that program, and according to the instruction given into the program and the information provided from the input devices, processor is going to decide some changes required into the output decide or output devices, and that changes is going to be provided to the output device through the use of output module. So the output from the processor will be first given to the output module, and that output module will convert the information required by your output devices, and that is going to be connected with the output module. So this is what we can say the major component of the PLC, which will be there in every brand. It will have the processor and power supply, input output modules, and the programming device. Now let us see in detail what is the IO modules. In the previous diagram, we have seen that the processor need to have the input information, and that is going to be provided by the input devices. But between input devices and your processor, we have to connect a input module. It's a specific circuit which is used to convert the type of your input provided by your input devices to the type or format required by your processor. For example, if you look into the DC input module, so in DC input module, from the input devices, whatever you say like switch or sensors, first there will be required to connect a current limiting resistor, and that is used to drop the voltage to the logic levels. Means it is not always that your all input devices is going to provide the information in the range of voltage required by your processor. So first this is going to be used there. After that, there will be a requirement of isolation between your outside input devices and the processor to avoid any kind of electrical hazard or the short circuiting task from the outside circuit to the processor circuit. So opto isolator will be there. And then after, there is the buffer filter circuits are there. This will be making your signal smooth and going to provide to the processor. So this is the detailed diagram you can say for the input modules, that this is the task going to be happen inside the DC input modules. Similarly, if we have the AC input module, then in the AC input module, one more thing extra is going to be added. That is, we have to get the converted your AC into DC. So there will be a rectifier and resistor network at the starting stage, and that will be converting first your AC information into DC equivalent, and that is going to be passed on to the processor through the remaining part of the circuit. There are some special purpose modules are also there going to be used in the PLC automation, like binary coded decimal, that is the BCD modules, some encoders modules, pulse counter input modules. For example, pulse counter input modules going to be used to interface with some field instrument that generate pulse such as positive displacement, flow meters and turbine type flow meters, etc. So these are the special kind of purpose module, and it is not going to be there with every PLC. It is only be there where it is required. So it depends on the your application where it is going to be used. Now, how the input devices are going to be connected to the input module. So if you just look at here in the diagram, here the three different types of input devices are shown here, and how it is going to be connected. Here first, that is the AC kind of inputs will be connected, means in the input module there will be a terminal for the ground. It will be connected to your ground point of your AC signals, and your push button, or you can say limit switch or toggle switch, will be connected like this, means one end of the switch is going to be connected to your phase terminal of the AC signal, and another terminal of your switch is going to be provided at the input pin of the input modules. Similarly, the thing in case of DC. In DC case, your negative terminal will be connected to the ground of input module, and the one end of the switch and push buttons are going to be connected with the positive end of the supply, and another end of the switch or push button is going to be given to the input pin of the input module. And in the case of TTL logic connections, means if you are using the transistor logic connection type of sensors, then it is going to be connected like this with the circuit. That is, your transistor will be getting the positive supply and negative supply from the terminal of the module, and the output pin is going to be given to the input pin of the module. Output pin means the collector pin of your transistor will be given to the input pin of the input module. So this is how the input device are going to be connected with the input modules. This is the very basic thing, but when we take a actual sensor or limit switch, there is also a various types of sensors are coming. Some are two terminal sensors, some are three terminals. So based on the sensors you have, you need to connect with the available terminal of the inputs modules of the PLC. Now, how the output device is going to be connected. Now, in output device connection, there is again two types. If you have the DC output module, it will be providing the DC output. That means when your output is required to be triggered or it is going to be made on, it will provide the positive signal at that output pin. So your output device will get one connection with the output pin of the module, and another end, or you can say other terminal of your device, is going to be connected with the ground or the negative terminal of the DC supply. So that is how your output devices are connected. If it is AC module, your another end is going to be connected with the neutral. So this is how your output devices are going to be connected with the output module. But here one more thing you have to understand, that in case of AC output circuits, which is operating with a high voltage like 120 volt, or we can say 230 volts, something high voltage AC, in that case, you need to check out the capacity of your module. Some modules are there capable with that voltage. So you can directly connect your 240 or 120 volts circuits to that module terminal itself. But if your module is not capable or rated with that voltage, you need to take a contactor, and that contactor will be connected with the module, and contactor can give you the high voltage connection to the outside components. So here this is a small diagram which is showing you the few inputs and output devices. Puts buttons, we are using some start stop button, and output devices like motor connection through contactor or some lamp indicator we can use. So this is very simple thing. Now let's go to the PLC operation. So what is the basic function of the PLC, typical PLC? So very basic thing your all PLC are performing is read all the field input devices that is going to be connected with your input modules. Then after it will execute the user program which you have stored into the PLC memory, and based on the program execution, whatever control scheme we are having taken, your program and your execution will be deciding that what change is required to the output devices. So according to that, your PLC will provide the output to either turn on or turn off the your field output devices, and according to that it will perform the whatever control tasks we are requiring to perform with the help of PLC. And this is process of sequential reading and input output is called the scan cycle or scan task. That means the PLC is reading the information from the input devices. It is called the input scan. Likewise, if PLC is giving the signal to the output devices, that is called the output scan. When PLC is executing the program, you can say it is the program scan or you can say program execution. So this is the PLC operation, and we can divide this PLC operation in various phase like this. The very first phase, we can say it is the phase of reading inputs. That's what we call as a input scan. So in this phase, your PLC is performing the reading of the condition of your all input sensors. For example, here you have connected, let's say, a start button at the PLC input. So in this phase, your PLC will be checking out that whether start button is pressed or not. So likewise, all the inputs, whatever number of inputs we have connected to the PLC input sensors, input modules, that is going to be scanned, and all the present status of your input devices are going to be taken into the program. After this phase of input scan, the next phase is for the program execution. After reading the condition of your all inputs, your PLC is going to check by one line your program. That means it is going to execute your program, that what instruction you have provided to perform in the sequential task. According to that program and the present condition of your input sensors and input devices, it is going to decide that what the thing required to be performed at the output side. So for that, your next phase is going to be diagnostic and communication. That is, according to your program execution, your PLC or you can say processor will come to know that what kind of change is required to be given at the output side. So that is going to be decided in the phase 3. And after it has been decided that for example, particular motor is required to be on or off, particular valve is going to be made on or off. So whatever task is required to perform at the output side, it is decided in your phase 3. And according to that decision, your PLC is going to provide the information to the output side module. That is what we call as the output module. And that is the phase number 4. That is the output scan. So once output scan is performed, whatever decision your PLC has taken, it will be available at the output side. So if your output motor is required to be on or off, that kind of signal will be coming at the output pin of the output module. So according to that, your motor is going to be on or off. So this is the complete process, and this is a closed cycle, you can say. Once outputs can get completed, PLC will again go to the phase 1. It will start reading the condition of your input devices, and the whole cycle will be repeated. So this cycle is known as the program cycle of the PLC, or you can say operation cycle of the PLC. And this cycle is going to be performed very fast. We can say one cycle time of PLC is going to be in terms of microseconds or nanoseconds. So this one whole cycle, that is including all 4 phases, is going to be performed by your PLC in a very short period of time. And that's why it is going to be very faster and going to check the condition of your input state, and according to that it will be giving you the task performing at the output side. Now, when PLC is connected in the system, what are the different types of indicators which is you can see on the PLC? That is, first very is that power on condition. That is, once your PLC is in on condition, there will be some green signal or green LED will be there, which will be showing you that your PLC is in on condition. Now in on condition PLC also, there is a various mode of PLC. That is, whether your PLC is in running condition mode, that means it is executing its program condition, or another thing is that you can have PLC in your programming mode. That means whenever you are adding new program to your PLC, you have to take your PLC into programming mode so that you can add or remove or change in the program which is there into the PLC. And if your PLC in the fault condition, there may be some red LED there which will be showing you that your PLC is right now in some fault condition. Now, what are the criteria you have to keep in your mind when you are selecting the PLC? So very first important thing you have to check with the condition of PLC, that is how many number of logical inputs and outputs you want, because PLCs is capable of handling so many number of inputs and outputs, and in market it is available with various number of inputs and outputs. And that's why you need to decide first that how many number of inputs and outputs you require to perform your automation task. So that is the very basic one and the important criteria which you need to decide first before you select any PLC. Then after, you require to select the memory size. In PLC, it is not like a personal computer that we are having a hard disk, so as much memory you require, it is there. No, PLCs are coming in the various size of memory also, and depending on that, it will be having a cost. So you have to just select the PLC memory size depending on your program capacity. That means you need to first check out with your program that what is the length of your program, how much memory it will require. According to that, you have to select your program. According to you have to select your PLC. Then after, some special IO modules if you required or not, because some PLCs are there which is providing you the extra some special IO modules. It might not be used in your automation, so you need to decide whether you required that or not. Because once that module get added into the PLC, it will add the cost. So you need to choose one which is you required. Then after, you need to see that what is the scan time. So this scan time, that is what I just discussed about operation cycle of the PLC. To complete one operation cycle of your PLC, whatever time it is taking, we call it as a scan time. So if you want a faster PLC, your scan time should be as much as smaller. So as scan time is going to be smaller and smaller, your PLC is going to be costlier. So depending on your requirement, in some case, if your scan time is, let's say, 10 microsecond is okay, then you need not to go with a smaller scan time, because that is unnecessarily increasing the cost. So you need to select a particular model of the PLC which will give you the scan time as per your requirement in your automation. Then after, what are the different types of communication you require from the PLC? That means you want to connect your PLC with your computer, or you want to communicate the PLC with another PLC. So which kind of communication you require? According to that, various communicating ports are available on the PLC. So if some communications you are never going to perform, then that type of communication port you did not require. So you can choose the PLC which is having the communication port which you require. And then after, which software you are going to use for that PLC programming. So these are the different criteria for the selecting a PLC. Now, how the size of PLC is going to be decided? As I just talked in the criteria of the selection of PLC, that based on the number of inputs and outputs, your size of PLC is going to be decided. And another parameter which is going to decide the size is the memory. So these two main parameters which is going to decide the size of PLC. And according to that, we are going to have the PLC in the different size. Like first is, we can say it's a small size PLC which will be having 120 IOs capacity and the memory size of 2 kilobyte. So this is going to be used in providing some simple to advanced level machine controls where you require to have less number of input outputs in limit of 180, 128 inputs and outputs, and a small memory that is of 2 kilobyte. Then after, we have the medium size PLC, which is having capacity to handle 2048 number of inputs outputs. This is the maximum I can say. It's not like that only 2048. It may be 2000, it may be 1900, but up to 2048 input output capacity PLCs are considered into the medium size PLC, and it is having the memory size 32 KB. You can see that as the number of IOs getting increased, obviously we required higher memory, and that's why memory size is also getting increased with the medium size PLC. The last one, that is, we call it as a large PLC, which will be used in some high sophisticated units only. There you need to have the very large number of inputs and outputs, up to, you can say, 8192 IOs it can handle, and it will be having the memory size of 750 kilobyte. So this is how we are having the different size of the PLC. Now, what are the different types of PLC? Basically, we have the mainly two types PLC. One we call it as a fixed type PLC, or you can say compact PLC, and another is we can say it's a modular PLC. Now, what is the difference between this? So first, if you see the compact PLC, it looks like this. Here in this PLC, you can say there is no provision to connect any extra thing with this PLC. Means the inputs outputs device possible to connect with this PLC is already going to be manufactured at that time fixed. Means no extra connection, no extra module you can add in this, no any special module, nothing. So this is what you can say a fixed PLC. Whatever manner manufacturing is done, then after you can use in that number of inputs and outputs only. So this is what the compact PLC. Then if you want to go with another type, that is what we call it is a modular PLC. In modular PLC, there is a provision, or you can say there is a flexibility to increase and decrease the number of inputs and outputs as per our needs. So in this case, for this PLC, you look at this. This is the modular PLC. In this, some number of inputs and outputs are there, which is already coming from the company, which we call it as the onboard modules. And in this onboard modules, we'll be having some limited number of inputs and outputs. If you need to have the higher number of inputs and output capacity, you just need to purchase the modules only, and you can connect that module with your PLC. That means your PLC is allowing to connect extra modules, and that's why this is a PLC which can be having capacity of inputs and outputs which can be increased or decreased, or it can also be added with the special kind of controllers or special kind of communicating modules or any other special purpose modules also. So this is what the advantage you get in the modular PLC, which is not there in the fixed PLC. Now, once you are going to have the PLC and you want to start with your industrial automation problem, some company hire you and given you the task that this is my plant working and I want to make this to be automated. So how you will start with your design process? Means how you will design your automation system with the help of PLC. So in that case, we are going to divide this designing process in various tasks. Very first task is we can say it is to understand the process. You need to understand your process thoroughly in a smaller step, means what the step by step process is going to be executed in sequential tasks. Means your whole process you need to first divide into smaller number of tasks, and that task is going to be step by step executed. Then after, according to the understanding you got from the process, you need to select the proper hardware and software required. That is particular PLC you need to choose. And then after, you can start developing the logic, or you can say program. So once you have understood the process, based on that you have selected the PLC, and then after you can start with developing the program or logic. And after getting the program, you can just start deciding the scan time and the memory requirements. So this is how we go with the design process. Now, what are the items you required when you are working with the PLC? The very first thing you require, that is the programming terminal. It may be either your laptop or desktop, which is going to be have installed the software which is provided with the company. For example, I am working with the Bose PLC. They are providing the Indra Logic software. For example, if I'm working with the Allen Bradley PLC, they are providing RS Logic software. So depending on company, they are having a different software which is going to be used to program your logic, and from that program logic you can use that software to dump your program into the PLC. So that's what you required first, programming terminal. Second thing you required is that PLC software that I just told. Means in your programming terminal you have to install that PLC software so that you can do the programming. Third thing is that communication cable. Means whatever program you have developed inside your programming terminal, that need to be saved into the PLC. For that you have to have either LAN connection or any other communication cables. Another thing you required is the backup copy of your ladder logic program, because once you are storing your program into the PLC, you can keep that program with you. So in future, if you need to change anything or modify it, you can do it. And another thing is that documentation. In documentation, you can have the uh, proper logic diagram, or you can see your program instructions set by set how you are working with. And you need to have the PLC manual also, because what are the inputs and output pin number connection, how the modules and inputs and output modules are going to be configured, what is the software manual, that is how you are going to use your software. So for that, all this thing is required. Now, what are the various programming language which we can use to program the our automation part? So there are various languages. Five most famous languages are, you can say, ladder language, LD language, structure text, functional block diagram, sequential function chart, and instruction list. So these are the five different language. But if I just tell you, out of these five, ladder language is most widely used in the industry. And it is not like that this ladder language is only feasible in everywhere or in all the automation part. It depends on your particular background. That means from where, for example, you are good with the C programming, then for you structure text is good language which you can have to use in your PLC. So depending on your background, your experience, and the application where you are working with, which language is preferable, that is going to be changed. But in most of the application, ladder language is suitable, and that's why most industry are working with the ladder language. Now, if I just talk in detail about ladder language, so in ladder language of programming of the PLC, we are having the different types of symbols for the different types of tasks. That is normally open context we are using here for representing a normally open contact of relay, then normally closed contact of the relay. So these are the two symbols we are using for representing the contact of the relay. Then the coil of relay is going to be represented with the help of this symbol. This coil is going to be energized based on the connection of your contact condition. That is the input connection of contact. If it is in on condition, then your coil will be getting supply, and we call it as a coil energized condition. Then there are some inbuilt function blocks are also available into your PLC software, like you can say timers, counters, pulse timers. So, or you can say logic comparison task, less than, greater than. So there are various type of functions are already inbuilt in your PLC software. So that you need not to program with your logic. You can directly use to with that function block. So that is possible there into the PLC. Now let us say, for example, I want to perform a AND operation in my ladder language. That is, I have a two push button, let's say A and B, and I have one output, let's say fan. We give the name to set C. So I say when I press that both the push button, then only my fan should go on. For remaining all condition, means either switch is on or both is in off condition, my fan should not go on. That is what we call as a AND operation. That is, I have to press A and B both, then only my C coil here get energized. Here you can say I have taken contact for A, contact for B, and the coil for C. So A and B is the push button that will be given the address of my input devices, and C is the coil which will be provided the address of output devices. So when I press from outside my push button A and B, this contacts of A and B into my logic going to be closed. That's why it will be making path from power supply to the coil. So your coil will get energized, and that coil energized means your output pin of the output module is going to be on, and that can make your fan on. So this is what you can say AND operation. So unless and until your A and B both pressed, your coil C will not get supply and you will not get output. So this is called the AND operation. Similar to that, you can have the OR operation. So here you can say you have to get OR operation means any of the switch can make your fan on. If I press A or B, it should make my switch or my output on. For example, you can take this is like your staircase wiring. In staircase wiring, we can say we want to make our lamp on either from ground floor or first floor. So you can put these two switch, one on ground floor, one on the top floor. So you can say like if I press A button or B, it will make my coil to be on, and that means your output can be on. So it's called the either operation or operation. Then not operation. In not operation, it is reverse task. That means if I press the button, my output should go off, and if I'm not pressing the button, my output should be on. So this is what the not task you can perform with the help of ladder logic like this. Now to understand the basic working of the PLC, let us we take one small example. Here you can see in the diagram, here one tank is going to be used to mix the two liquids. The two liquids are coming from the two valves, that is valve A and B, and one motor is going to be used here to mix up that two liquids properly. And output drain valve is also there, C. So after your liquids get properly mixed, your output should be taken out from the valve C. So this whole process is divided in step by step like this. You can see here your tank is used to mix these two liquids. So once you have understood this process, as I discussed in the previous thing, that the whole design process, it starts with understanding the process. After you understand the process, you need to divide it in smaller tasks. So what are that smaller tasks? We can divide it like this. So the very first task you can say, like when the start button is pressed, your solenoid A and B, that is your valve A and B, should be energized. So your liquid from two different tanks from valve A and B will start coming into the tank. And after that, your next task is that when the tank is filled with the, here you have to use the float sensor. It will be indicating you the liquid level into the tank. So once the level is achieved, it will give you the trip signal, and that can be used to stop valve A and B. And once your valve A and B have been stopped, you need to start your motor, and that will be mixing the liquid. Once the motor is going to be permitted to run, it will be allowing to run for 1 minute here for mixing it properly. So we take the time for 1 minute for motor. So your motor should remain on for 1 minute only. And after 1 minute, your motor will stop, and the drain valve C, that will be turned on, and that's why your liquid can be drained out. And after your valve C get on, it will be draining out all the liquids outside. And once the tank will get empty, your float switch, that is the level sensor, will be again de-energized, and then after the process will start again. Means your liquid will come from A and B, and whole cycle will be repeated. Apart from this whole cycle, we have to add some extra thing is also there, that is the stop button we have to add. That means whenever you want to stop the process in between, you can have the stop button, so that your process can be stopped immediately there. Another thing is that we can provide the overload protection to motor. That is, if your motor get overloaded, then also your whole process should stop immediately. And the cycle which we have decided, that should continuously run unless and until you press either your stop button or your motor get overloaded. So this is what our whole process, and how it is going to be programmed in PLC. So for that, let us see this logic diagram here. So here you can see the, in ladder logic, here you can say on the left side, you see the number 000, 001, 002, 003. This is called the rung number. So this one part 000 is called the one rung of the ladder logic. Similarly, 001 is called the another rung, then 002 and 3 in sequence. So here the very first thing we have to use is the start button first, from where we starting our system. So in logic, first I have taken the normally open contact of the start button here, and this start button when pressed, if your stop button and your motor overload contact is not activated, that means you have not pressed stop or your motor has not get overloaded, then after pressing start, you will get your master coil energized. So when master coil will get energized, we can take one contact of master coil across the start button, so that you can release your hand from the button. Means once you start, you can release your hand, and because of this master coil contact connected with the start, your master coil will remain energized. Now this master coil will only be de-energized either you stop or your motor will get overloaded. Apart from that, your master coil will remain on. Now we can start further. That is, your next run will start with the on NO contact of the master coil. That means if your master coil is on, now you can see your master coil is only on when you have pressed the start button. So that means master coil is on. That means you have started the process. So if you have started the process and if your level of the tank is not achieved, that means your tank is empty, then your inlet valve A and B both will be turned on. That means two coils here connected for the valve A and B that will be energized. Because of this, your input valves A and B will be turned on. So liquid will start coming inside the tank. Now this liquid will be allowed to enter into the tank unless until your level of the tank will be achieved. So as soon as your level of the tank will get achieved, your float level contact will get open. So your valve A and B will be open, or you can say it will now stop entering the liquid into the tank. And after that, as float level here get closed, you will see that uh, your motor will get started. And as soon as your motor will get started, in rung number 3 we have used that motor contact here, so it will start this timer, and this timer is right now set for the 60 second, that means for 1 minute. So for 1 minute your motor will be allowed to run, so it will mix up the properly into the two liquids. And once the 1 minute timer will get over, this here you can say the timer contact we have used in series with the motor, that is T40DN, that is called timer done contact. Once the timer will complete the task of timing, this contact will be energized. That means here NC contact we have taken, so it will get open. So your motor supply will be disconnected. So motor will stop. And once motor will stop, you will have the output, that is your outlet valve should be turned on. So once the motor will be stopped here, you can say that once the mixing time get over, your outlet valve C will be turned on, and it will remain on unless your float level valve get energized again. So as soon as your your tank will get empty, this float level valve is again get empty, so it will be open. And this is how your whole system is going to work. So this is, you can say, the very simple thing. We have just talked about this process. In this picture, you can see that two inlet valves are entering or allowing the liquid to enter into the tank, and this motor is used to mix up that liquids properly. This float sensor is giving the indication of your level of the liquid into the tank, and outlet valve C will be used to drain the liquids after your liquid get properly mixed. So this is the small task we have taken here as an example, and based on that, how the design process we can execute. That is how we can understand the process. Based on understanding, how can we have division of the sequential task step, and based on that, how can we develop the ladder logic. That is what we have understood here. So this is all about I want to talk here today. So if any questions, it can be entertained now. Okay, so if you have not any question, we can end here. Thank you all for attending this webinar. For further query, you can meet me personally. We can discuss on your queries.